Scientific notation. Scientific notation is numbers that look like this. That is, they've got a number to start with one digit, one numeral, in front of the decimal point. And that can't be a zero. So a number with one digit in front of the decimal point, not a zero. And then scientific notation has a multiplication by a power of 10. And that power of 10 could be positive or negative. So this is a positive power of 10, this is a negative power of 10. Scientific notation is used for writing very large or very small numbers. And we do that partly so it fits on a calculator more easily, and partly because it's easier to make sure we don't miss a zero, so we don't accidentally put an extra zero in or leave a zero out, because that would be quite bad. So how it works is it's based on powers of 10. And if we have a quick look at some powers of 10, I'm actually going to start with 10 squared because that's nice and easy. That's 10 times 10, which is 100. 10 cubed. To get to that from 10 squared, I've obviously multiplied by 10. And I've got 1,000. So powers of 10 are going to be 1 with zeros after them. If I times 10 again, 10 to the 4, I'll get 10,000. We can put a comma in after each 3, counting this way if we want. The comma doesn't actually mean anything, it just makes it easier for people to count the zeros. It's not like a decimal point that means things. And of course, if we kept going, times 10, we keep getting more and more zeros, bigger and bigger numbers. Now you'll notice that the number of zeros is the same as the power. So 10 to the 4 are 1 and 4 zeros. It's kind of handy. If we work back the other way and get some smaller powers of 10, to go back this way we would have to be dividing by 10. 10,000 divide by 10 gets me 1,000, divide by 10 gets me 100. Divide 100 by 10, and we quite obviously get 10, which is just an interesting point because you'll notice that 10 to the 1 equals 10, so it's telling us that anything to the power 1 just equals itself. If we keep going back in our powers, divide by 10, my power pattern, 5, 4, 3, 2, 1, well this would be 10 to the 0. 10 divided by 10 is 1, which tells me another rule that we know. Anything to the power 0 is 1. If we keep going back with our powers, I will get to 10 to the negative 1. I've got to divide by 10 again. So 10 to the negative 1, 1 divided by 10, that's either 0.1 or I could write as a fraction of 1/10. And 10 to the negative 2, 0.01 or 1 over 100. It's just worth looking at this, sorry I got a bit cramped at the edge there, because we can see that repeatedly dividing by 10 or multiplying by 10 gives us our powers. And we can also see what negative powers mean. So 10 to the negative 1 is 1 divided by 10. 10 to the negative 2 is 1 divided by 100. If we keep having a bit of a look at what this means for scientific notation, Now this is just an example to look at how it works. We don't need to write this in an expanded form like this, but this means 3.604 times 10 to the 5. 10 to the 5 is 100,000. Or it means times 10 5 times. Not multiply by 50, but times 10 times 10 times 10 times 10. So, since we remember that when we're multiplying by 10, in fact, let's just type this into the calculator. 3.604, oh, you can't see me there, times 10 to the power 5, 360400. Remember, when we're multiplying by 10, we move our decimal point one spot to the right. So really what I've done, 3.604 times 10 to the power of 5, is I've moved my decimal point 1, 2, 3, 4, 5 spots. I've rewritten the number 1, 2, 3 movements of the decimal point, and then since I had to jump it twice, I need to add in 2 more zeros. 2.3 times 10 to the negative 2. That would be 2.3 times 10 to the negative 2, 0.01, or it's the same as dividing by 10 twice. And when we're dividing by 10, we move our decimal point one spot to the left. Now, if you don't remember why this works, check in with your teacher. So if I do, sorry, try to move that so you can see it, 2.3 times 10 to the power negative 2, 0.023. Effectively what I'm doing, I have to divide this by 10 twice, take the decimal point, move it once, twice, rewrite the number, decimal point, there was a spare jump there with a 0, 2, 3, and if I've got a decimal point on the left of a number, I make sure I've got that leading 0. And we were right there. So really, all we're doing is multiplying or dividing by 10 multiple times by moving that decimal point. So, that's why it works. If I'm converting from scientific notation to decimal form, or writing it as a basic numeral, simply rewrite the number and move the decimal point this number of spaces. If it's positive, we need to make it a bigger number, we move to the right. If it's negative, we make it a smaller number, move to the left. 9, 3, 4, and the jumps we do, you can draw them on your question if you want. 1, 2, 3, 4, 5. I'll need 3 zeros after that. Do make sure though that you don't just do that. This is not an answer. You've got to write it as a normal number. This one, 4.701 times 10 to the negative 6. We're going to go 1, 2, 3, 4, 5, 6. That means I'll need my leading 0, my decimal point, which ended up here. 1, 2, 3, 4, 5 zeros. 4701. Sometimes you'll need to convert when you get it on the calculator. So if I try doing this on the calculator, 150,000 times 250,000, it won't fit on the calculator, so it will give me scientific notation. If we then write down the answer, that's an acceptable answer, but I want this converted to decimal form. 10 to the 10 means I'm going to move my decimal point 1, 2, and another 8 zeros. If I want to put the commas in to make it easier to read, I start from here and I put them in every 3, but they don't actually need to be there. Very large number. When I'm converting numbers into scientific notation, what I will need to do is rewrite the number with 1, not 0, digit before the decimal point. Now what that means is that this one is going to be written as 4.5 because I get rid of start and end zeros. Easiest actually to make sure there is 1 0 after the decimal point. So this one here, I'm going to write it as 4. I'm going to need at least one number after the decimal point, so 4.0. But after that, no start or end zeros. So these zeros go away, these zeros go away. These zeros will go away, but not the one in the middle, because we can't change the meaning of the number. So this will be 3.062. Then we multiply, by a power of 10, and the power of 10 will be depending on how many spots we had to move the decimal point. So I had to move this 1, 2, 3, 4, 5, 6 points, and it's a very large number. This is a very small number, so from here to get back to that, I'd have to multiply by 10 to the 6 to put all these zeros back in and make it a big number. Very small number will have a negative power of 10. How many spots did I have to move the decimal point? 1, 2, 3, 4. 10 to the negative 4. Because to make this back into that number, I would have to move my decimal point by dividing for negatives. Another small number. Count how many places I moved the decimal point. 1, 2, 3, 4, 5. Negative 5. A negative number. This is not the same as a negative power. This is just negative very large number. Negative 7.205. Don't need those last zeros. Times 10 to the power. How many times did I move the decimal point? The decimal point was there. 1, 2, 3, 4, 5, 6. Large number, positive power. So that is scientific notation.